Hey folks, welcome to my channel number 10. So there we have the problem on the screen. Integrate the following with respect to x. We have 8 to the power 1 plus x plus 4 to the power 1 minus x, the whole divided by 2 to the power x, right? So what we've been given is dy by dx and we've been asked to find what is our y. So my y is nothing but integral of the given expression, right? So let's write down what is our y in the next line. Now, before we actually jump to solving for y, I noticed that my expression given to me is not in a simple format whose antiderivative I know from first principles, right? So how do we go about solving that? Looks like we might have to use some of the rules and exponents what we know or what we will learn in this particular video. So I'm going to write down all the rules which are applicable in this particular problem. So there we are. I'm going to be using these three rules and exponents to solve this particular problem or to simplify the expression what has been given to us. Okay, so we have a to the power m plus n equals a to the power m into a to the power n. A to the power m divided by a to the power n equal to a to the power m minus n, and a to the power m, the whole power n equal to a to the power m into n, right? So let's go back to our expression. I'll keep y aside for a moment. I'm going to paste my expression and start simplifying it. I have this particular expression which I know that I can rewrite it as a to the power 1 plus x divided by 2 to the power x plus 4 to the power 1 minus x divided by 2 to the power x. Now I know a to the power m plus n equal to a to the power m into a to the power n, right? So I'm going to rewrite a to the power 1 plus x. Here in the first expression, a to the power 1 plus x equal to 8 into 8 to the power x, okay? Similarly, I know that my 4 to the power 1 minus x is 4 to the power 1, which is nothing but a 4, into 4 to the power minus x, right? Again, I use the same formula a to the power m plus n equal to a to the power n into a to the power n. So now I know my 8 to the power x, right? What is my 8? My 8 is nothing but 2 cube, right? So why am I actually representing it this way? Because I'm trying to draw a connect between the numerator and the denominator in each of these expressions, right? So when we have the first expression, which is 8 into 8 to the power x divided by 2 to the power x, I want to draw a connect between the numerator and the denominator, right? And I use this particular formula, a to the power m to the power n equals a to the power mn, right? So far, we used a to the power m plus n equal to a to the power m into a to the power n, which is the formula we used in the earlier step. And now we're going to use a to the power m to the power n is nothing but a to the power mn. Okay. So when I write my 8 as 2 cube, it becomes 2 cube to the power x, which is nothing but 2 to the power 3x, right? And then I go to the next part, I have 4 to the power minus x, right? So again, what is my 4? My 4 is nothing but 2 square, right? So I have 2 square to the power minus x, which is nothing but 2 to the power minus 2x. Again, we use the same formula, which is highlighted in yellow above, a to the power m to the power n equals a to the power mn, okay? Now I'm going to use the other formula what we have written, right? A to the power m divided by a to the power n equals a to the power m minus n. So now you will understand why I tried in representing everything in terms of 2. Okay, so if I draw a parallel to the formula written down there, my a is nothing but 2 right now, right? For the formula a to the power m divided by a to the power n equals a to the power m minus n, right? So let me apply that particular formula and see how I can simplify this expression. So this time I will have 8 times 2 to the power 3x divided by 2 to the power x, right? So my a equals 2, which means I have 2 to the power 3x minus x. And what is that? It's nothing but 2 to the power 2x, right? And then similarly, I have plus 4 times 2 to the power minus 2x divided by 2 to the power x. Again, I apply the same formula, and what do I get? 2 to the power minus 2x minus x, which is nothing but 2 to the power minus 3x, right? So it looks like we have simplified this, right? And I'm going to do one more step before I actually go back to my why, right? And you will understand why am I actually doing this. I want you to remember one more useful identity, right? Either you remember integral of a to the power x, or you remember this particular identity whenever it comes to solving problems, right? E to the power ln a equals a, right? Which means I can rewrite my expression like this, right? What is my 2? It is nothing but e to the power ln 2, okay? Right? So I have a 2 ln 2 in the first part, and then I have a minus 3 ln 2 in the second part, right? Both contained in e to the power terms, right? Now, both of these are constants, right? My ln 2 is a constant, my uh, 2 and minus 3 are constant. So I have a function of the type e to the power x, right? Now I go back to my y, right? Let us copy down the earlier y what we just wrote. I'm going to rewrite this using the simplified expression what we have right now in front of us. So now I'm going to apply the rule of finding the integral of f of ax plus b when you know the integral of f of x, right? Let me write that down. This is the one. If integral of f of x dx equal to g of x plus c, then integral of f of ax plus b times dx equals 1 by 8 times g of ax plus b plus c, right? So I know my f of x now. My f of x is nothing but e to the power x, right? Then my g of x will also be e to the power x, right? Because I know that integral of e to the power x dx equal to e to the power x plus c, right? And then I have my f of ax plus b. In the first case, it is e to the power 2 ln 2x, and in the second case, it is e to the power minus 3 ln 2x, right? So now before I actually jump to solving this particular problem, I'm going to break this using the sum rule, and I know that my y equal to, all that we've done is applied the sum rule, and I go to the next step, and now I know that I'm in a position to apply the rule which we just spoke about, right? So what is my f of ax plus b? In the case 1, remember folks, we are now in the first expression. Plus b is nothing but e to the power 2 ln 2x, right? So what is going to be my g of ax plus b, right? My g of ax plus b is nothing but the same expression, right? And similarly, when my f of ax plus b equal to e to the power minus 3 ln 2x, right? Let's write that down as well. So similarly, when f of ax plus b equals e to the power minus 3 ln 2x, then my g of ax plus b also will be e to the power minus 3 ln 2x, right? So I go back to my y. My y is nothing but I pull out the 8, right? The 8 can be pulled out of the integral. I have integral of e to the power 2 ln 2x, right? Which is of the type integral of f of ax plus b dx, right? So the answer to that particular problem is 1 by 8 times, right? And what is my a? In place of a, I have 2 ln 2, right? And then I have my g of ax plus b, right? I hope you folks are with me. If you've not understood this particular step, please do write to me in the comments. I'll be happy to support you. And similarly, I pull out the 4 and I have integral of e to the power minus 3 ln 2x dx. Again, it's a problem of the type integral of f of ax plus b dx, right? Where your f of ax plus b this time is e to the power minus 3 ln 2x, right? So what is my answer to that particular integral? It is 1 by 8 times. Again, in place of a, you have this time you have minus 3 ln 2, right? And then I have my g of ax plus b, which is nothing but e to the power minus 3 ln 2x, right? So now I know that I can do a little bit of rearrangement. And remember, folks, I have my constant, right? I can do a little bit of rearrangement and simplification. So I have first expression 8 divided by 2 ln 2, which is nothing but 4 by ln 2, right? And then I come to the second part. I have 4 divided by minus 3, which is nothing but minus 4 by 3, right? Now I can do a little bit of further simplification. I know that my e to the power ln 2 is nothing but 2, right? So I can rewrite this particular expression as 4 times my e to the power ln 2 is nothing but 2. So I can rewrite this as 2 to the power 2x, right? Divided by ln 2 minus 4 by 3 times. Again, we do something which is very similar. I will have e to the power ln 2 as 2, but this time I will have 2 to the power minus 3x, right? I know that my 4 can be expressed as 2 square, which means I will have a 2 square into 2 to the power 2x, which means I can rewrite this as 2 to the power 2x plus 2. And then I have my second expression again, which can be rewritten as my 4 can be written as 2 square, and then I have a 2 square into 2 to the power minus x, which is nothing but 2 to the power minus 3x plus 2. So I hope you folks are with me in this particular step. So all that what we did was I have this particular expression e to the power 2 ln 2x. I know that I can rewrite it as e to the power ln 2 to the power 2x, right? Again, using one of the rules that we wrote about. And I know that my e to the power ln 2 is nothing but 2. So this part, let me highlight it in yellow. E to the power 2 ln 2x is nothing but 2 to the power 2x, right? So that's what we did in step 1. And in step 2, I rewrote 4 as 2 square, and we have 2 to the power 2x into 2 square, which is nothing but 2 to the power 2x plus 2, right? So all of them are using the identities what we wrote before beginning to solve the problem, right? These three identities, please do remember them. Please understand how we arrive at these identities. And this is e to the power ln a equal to a is another important identity that I would suggest you to remember, right? Now we come back to our final answer. So that's our final answer. So there we are. y equals 2 to the power 2x plus 2 divided by ln 2 minus 2 to the power minus 3x plus 2 divided by 3 ln 2 plus your constant c. Right? I hope you found my content useful. Please do subscribe to my channel and support. Thank you.